homework and one is, okay, so this is a new addition to the AP curriculum. It really should have been done before we tested on this last thing, but I kind of forgot about it. So it will not be tested. I am. Okay. It will not be tested except until you get to the midterm. I know you're excited to see your friends, the limits back.
Yeah, I know.
Okay. It's pronounced L'hospitals, as good as I can pronounce it. That S there is silent, and I think it's French.
So where
Is it French? Okay.
Where should we put this? Like in
Put it.
Like,
Put it in your last chapter, and
what do we call it?
L'hospital. There's not a section. L hospital. Yeah. Okay. I mean, you can have a separate thing. It'll be. It's basically a rule that we should have put. We could have put with our other limit rules, but we didn't know about derivatives when we were studying limits, so that's why we couldn't go there. But this is new to the AP curriculum as of this year. I know when I talked to a couple of girls that have the college calculus, they were like, oh, we didn't talk about that. I said, no, it wasn't part of the curriculum. So anyway, okay, so this is a very specific method. It's only used if we end up with limits when we plug in that look like that. Okay, so here's the rule. The limit as x approaches whatever, I can't read that, what does it say, a? Okay, of f of x over g of x, when you plug in a, you get 0 over 0. Now, before, you would have said, okay, that's not going to work, so now I can either do some algebra to maybe factor, I can do maybe some conjugate work, you know, all that. That is not to say we can throw all that out now, okay? But that's, or we ended up as x approaches a with an infinity or negative infinity when we plug in. Okay, so here's how L'hospital works. A is any real number, infinity or negative infinity, so this can be any of those numbers, or not even a number, infinity and negative infinity. Okay, the limit of f of x over g of x is the limit, same limit as f prime of x over g prime of x. Okay, so you just keep taking derivatives until you can plug in. All right, now just beware, this only works on quotients. Okay, but sometimes we can make a product. Look what we did. We made this product a quotient. There is a division bar here. Just disappearing. Okay, we divided by f of x, so that's how we get that or that. So there's not, that's not, but it's very specific, and all I have is some nasty examples. See them? Okay, so first thing that you do when you're doing a limit is what? Try to plug in. Okay, so we're going to do that. We're going to make 2 sine of 0 minus sine squared of 0 over 0 minus sine of 0. What's 0? What is sine of 0? So I get a 0 on the bottom for sure. Am I going to get a 0 on the top? Okay, so this would mean, if we get 0 over 0, that we're going to use L'hospitals. Okay, so here's what it works. Here's how it works. Limit as x approaches 0 of the derivative of 2 sine of x minus sine squared of x over the derivative of x minus sine of x. Okay? Now, once you get used to it, you don't have to spell that out. You can just find the derivative. Okay, don't lose your limit because that's kind of important. All right, what's the derivative of 2 sine of x? 2 cosine of x. All right, and what's the derivative of sine squared of x? 2 sine of x times
2 sine of x cosine of x.
Yep.
something before, or was it one time?
Yeah. Remember, it's, for those of you that are using chain rule, it's u squared, where u is sine of x, 2u times cosine of x, 2 times sine of x, cosine of x. Yes, that is the chain rule,
Well,
yes.
I know, but like, would you need to?
I kind of do a power rule chain, where you just pull around the 2, and then you have this one down to 1, which is this piece, and then you take the derivative of the inside. But you may not be ready for that yet, I don't know. Okay, what's the derivative of x? 1. What's the derivative of sine of x? Okay. Now we're going to try and plug in a 0 again. Okay, 2 cosine of 0, what's that? All right, so far so good. Minus, what's 0? Okay. 1 minus 1. Okay. Cosine of 0 is 1. Okay. All right, so guess what?
You have to do it in double
again. Okay.
Doors.
Let me scoot it over here. But think of your alternative is, I mean, how else would you do this ugly thing? You could put it in your calculator if you had a, okay, so this doesn't work, so we're going to do limit x approaches 0. I'm going to not write the derivative because I'm running out of room. What's the derivative of 2 cosine of x?
Negative 2 sine of x.
Negative 2 sine of x, good. And that's 0, right? When we plug in 0? Okay. 2, what's the derivative of sine of x times cosine of x?
2 cosine squared x minus 2 negative 2 sine minus 2 sine negative 2 sine squared.
Oh, wait, sorry.
2 cosine squared.
So I'm just going to put it in the product rule right now and not have to worry about it cleaning up. Okay, so I take the derivative of sine times cosine plus, yikes, sine times negative sine. Yikes. That's really bad.
All right, well, we're
Okay, is that going to give me, all right, I'm going to group it and make it smaller since y'all have it already in a miniature. Okay. Let's work. Not too messy. Okay. Now, first of all, before I finish, that's not going to give me 0 again, is it? The bottom won't. Okay. So what's the derivative of 1? 0. What's the derivative of minus cosine?
Just kidding. The bottom's gonna give you 0.
Okay.
Just kidding. That's whatever.
Do what?
Isn't all positive? It's minus cosine.
Okay.
So you're gonna get 0 against each this again.
Wait. I think you do this. I don't remember how to do this 16 times.
This is actually.
Oh my god. It's like almost as bad.
That's probably why we're already having to do it. Are you serious?
You what?
We go literally the same distance from your water bottle.
All right, let's try this. Just because I'm going to come back to it. Let's try this one. Do you all remember this one?
Isn't that? Oh yeah.
Equals
Literally,
It equals
1.
1. Okay, so let's say we didn't remember it. Let's try L'Hospital's rule on it.
Let's just
You do
memorize it.
remember it.
Yes, if you remember it, you're good. Then you move on and you got more time to work on something else. But if you don't remember it, L'Hospital works. Okay, so I'm going to write that out. All right. Because when you plug in sine of x, that's 0, sine of 0, right? and 0. So we got the 0 requisite. Okay, so what's the derivative of sine of x? Okay. And on the bottom, 1. Praise the Lord. Okay, wow. Okay, so that is one that you remembered. Who remembered it, honestly? Anna did. And Emma, do you remember it? After Hannah said it?
I didn't really know.
Okay.
I didn't really hear you for that. So.
All right, so let's plug in, see what we got here. X e to the 0 is what?
1.
Minus cosine 0 is? That's 0. 4 sine of x, sine 0, there's your 0 for 0. Okay, so we know we can use L'hospitals then. Here we go. All right, I'm not going to write out the derivative. I'm just going to find the derivative. I don't know what I'm doing that line there. Okay, ready? All right, what's the derivative of e to the x? And the derivative minus cosine? Right? And the derivative of? Okay. All right. Plug in 0. E to the 0 plus sine of 0 is 1. Really? I thought we were saying it all along. The sine of 0 was 0. Oh, I thought you were asking
1 plus. Okay, it equals.
Okay. 4 times cosine of 0 is
4.
Okay, so we got 1 over 4. There's your new limit. Okay. All right. We got another x equals x approaching 0. So let's do 1 minus 1. That's definitely 0. And ln of 2 minus 1. What's the ln of 1? Yes. Okay. Hope you're not guessing. So we can use L'hospitals, right? All right. So what's the derivative of the top? Negative e to the x. Okay. What's the derivative of the bottom? Don't say it out loud. Just do it, and then we'll regroup here.
Are we supposed to know that ln of 1 is 0?
Yes. All right. So it's got my derivative here. Oh.
Negative dx over 2.
Very nice. Oh my God. Okay. All right, plug in your 0. We got negative 1. If we plug in a 0, right? We got negative 1 here. 2 minus 1, that's not 0. Okay. So negative 1 over 1 over 1, which is 1. Okay. All right. So I'm not sure. We'll come back to that one. Do what? A lot of times they are. Honestly, they're not real ugly. Okay. Now we got 2 over here that are going to infinity. Remember, L'hospitals doesn't just work with a defined number; it also works with positive or negative. Okay. Now, that e to the x might throw some of you all, because otherwise we're thinking that might be 5/7. No, because of the whole degree thing. Do what? Okay. What's the degree rule when we're going to infinity and negative infinity? The degrees are the same. Ratio of the leading coefficients. Okay. Anyway, what does e to the negative x look like as far as a graph? Remember that's 1 over e to the x, right? Does it look like this, or does it look like this? Second. Okay. So it looks like this. All right. So just keep that in mind, because we want to use that. If we just visualize, we go to infinity, 5 times infinity. Okay, and then this ends up infinity. This ends up getting close to what? Okay, and 7 times infinity is infinity, right? So we have this weird form. Okay, so let's try L'hospitals and see what happens. All right, what's the derivative of 5x? And the derivative of e to the negative x?
X times negative e to the x?
Yep.
Oh,
Yep. E to the u equals negative x, e to the u, negative 1, e to the negative x times negative 1, negative e to the negative x. That's your chain right there. Okay, what's the derivative of 7x? Okay. Now, I'm not going to get infinity anymore. All right, what did we say this was as we approach infinity? So, yes. So that works if you forget the degree thing, which some of you do. Okay.
So does the degree thing work?
Yes. Well, sometimes it depends on how it was in there. It probably would take over because of this business is going to go to 0, so you could kind of ignore that. Yes. So it would work. Did you have a question? Okay. I thought you said wait. No, you're good. Okay. Now, this is a product. L'hospitals doesn't work for a product. Very good. I think you're close.
So x over e to the x?
X over e to the x, yes. Okay. Because that's the same thing. All right, now if we put in infinity, basically kind of plug in infinity over e to the infinity. E to the x looks like what? Not this, but this, right? Okay. As we approach infinity, e to the x also approaches infinity. So this is when we plug in, kind of, we get that. Okay, so that means we can use L'hospitals, right? Limit x approaches infinity. 1 over, no, e to the x. Okay.
Which also is negative x.
Okay, so let's do it again then.
You're just going to keep doing it.
Oh, wait,
I got it. We can look at 1 over e to the x, but that's negative x, and then we want to graph it down to 1 expression.
You want to say that again?
I don't know if
You
it
all
makes
want to
sense.
listen?
Okay. E to the x.
When you get to this point,
Yeah, 1 over e to the x also equals e to the negative x. We just looked at what the graph of e to the negative x looked like in the previous problem. And as e to the negative x approaches infinity, it's approaching 0. Right. So it's just
so you're good. So you don't have to keep going technically, but that's just one method, and that's all we're talking about. It is kind of a nice method. Sometimes it's like annoying, and I'm gonna. Why don't you all get going on your homework and let me just read you this. What? I'm gonna go look at it and see what we did wrong. Okay, it's only okay. So back to this, we should have gone right here and did sine of 2x. Now we are still gonna get sine of 0, right? Sine of 0, 0, but what's 2 cosine of 0? 2. So does that work? 2 minus 0 over 1 minus 1. That's still 0.
It's 1 minus 0.
1 minus 1, right, is 0. Okay, so let's try it again and see what happens. All right. Derivative of 2 cosine of 0 is negative 2 sine of x, right? Plus, all right, chain rule here, ladies. What's the derivative of sine 2x?
2 cosine
And there's
2x.
2 cosine 2x. Good job, Anne. Okay. And sine of x, right? Okay, so it's 0.
Literally still 0 in the bottom.
Okay, we gotta do it again. It is a bad one, especially the first one.
Yeah,
All right, forget it, forget it.
This is so helpful, you guys.
Especially for the first one, so let's just forget it. Delete.
All right.